February 14th, 1943. Kasserine Pass, central Tunisia. The air smells of dust and cordite. A cold wind cuts through the Atlas Mountains, carrying the metallic clatter of tank tracks echoing between rocky slopes. Somewhere beyond the ridge, German artillery thumps methodically, each impact measured, confident. A panzer officer lowers his binoculars and smirks. Down in the valley, olive drab shapes are moving. Medium tanks, high silhouettes, oxy turrets, American M4 Shermans. To the men of the 10th Panzer Division and attached Afrika Korps units, these vehicles look almost comical. Thin armor, a tall profile, a 75mm gun that, on paper, shouldn't threaten a Panzer III, let alone the newer Panzer IV Ausfaith. German engineers back in Kassel and Stuttgart had already passed judgment, technically crude, under-armored, overbuilt. A tank designed by committee. The German crews have nicknames for Allied armor: Tommy Cookers, Ronsons, tanks that burn when hit. As the Shermans advance cautiously, engines growling, the Germans believe they are watching another example of American industrial excess: quantity over quality, noise over finesse. Then the valley fills with more of them. One Sherman crests the ridge, then another, then 10 more. Radios crackle, dust clouds multiply. The panzer officer's smirk fades. He raises his binoculars again, scanning left, then right. They keep coming. Inside a Sherman named Arkansas Traveler, Sergeant John McAllister grips the turret ring, sweat running down his neck despite the winter air. The interior stinks of oil, cordite residue, and unwashed bodies. The engine behind him roars like a living thing. He can feel every vibration through the steel floor. This isn't the tank he trained on back in Louisiana. This one has already crossed the Atlantic, been unloaded under threat of air attack, driven hundreds of miles, and repaired twice in the desert with parts scavenged from other vehicles. It still runs. Enemy armor, 11 o'clock, the gunner shouts. McAllister peers through the periscope. German tanks. Dug in, hull down positions. The kind of textbook defensive posture American instructors warned about. His stomach tightens. He knows the numbers. He knows the Sherman's frontal armor won't reliably stop a high-velocity 75mm round. He knows the German gun outranges his. What he doesn't know, what no one here fully understands yet, is how many Shermans are behind him. The order comes. The column spreads. Engines rev. Tracks bite into rocky soil. The first German shot slams into a Sherman on the flank. Armor screams. Flames burst from the engine deck. The turret hatch blows open. Black smoke rises, sharp and oily. German gunners nod to each other, just as expected. But the American tanks don't retreat. They maneuver. Shermans fan out, moving faster than the Germans expect. They don't sit still and trade shots at long range. They close the distance, firing on the move. High-explosive rounds slam into panzer positions, shaking crews, cracking optics, collapsing sandbagged revetments. Smoke rounds bloom, blinding German gunners. Another Sherman takes a hit, then another. Yet for every burning wreck, 2 more roll forward to replace it. German commanders begin issuing orders to reposition, to conserve ammunition, to focus fire. But the battlefield is changing too quickly. Radios buzz with overlapping reports. More tanks approaching from the south, enemy infantry advancing with them, artillery requests piling up. Back in Germany, engineers had argued that a superior tank would dominate any engagement. Precision mattered. Armor thickness mattered. Gun penetration tables mattered. And in isolation, they were right. But here, in this valley, isolation does not exist. A Panzer IV fires again, knocking out a Sherman at close range. Before its loader can slam another round home, a different Sherman, one the crew hadn't even noticed, fires into its side. The German tank shudders, then goes still. Its crew scrambles out under machine gun fire from American infantry advancing behind the armor. The German officer lowers his binoculars slowly. This was supposed to be simple. Attrition favors the better machine. That's what the manuals say. That's what the engineers promised. Yet, as the afternoon wears on, the battlefield tells a different story. Disabled Shermans are dragged away at night and replaced by fresh ones by morning. German tanks knocked out today will not be replaced next week. Spare parts are scarce. Fuel is rationed. Crews are irreplaceable. For the first time, a quiet, uncomfortable realization begins to form. Not in Berlin, not in design bureaus, but here, under the North African sun. The Sherman is not here to win duels. It is here to keep coming. Months earlier, years earlier even, the outcome unfolding in Tunisia had already been decided, not by gunners or commanders, but by men in drafting rooms. In Germany, tank design was an engineering contest, a matter of precision, metallurgy, and ballistic tables. The Wehrmacht did not merely want tanks, it wanted the best tanks. Machines that would dominate through technical superiority, fewer in number but unmatched in capability. At the Army Ordnance Office in Berlin, engineers spoke the language of millimeters and degrees of slope, armor thickness, penetration values at 1,000 meters, gear ratios, final drive stress limits. A tank, to them, was an instrument of perfection. When reports of the American M4 Sherman began arriving in late 1942, they were received with thinly veiled contempt. The Sherman's armor was thinner than German standards preferred. Its silhouette was tall, almost indecently so. The 75mm 3-gun, optimized for high explosive support, lacked the raw armor-piercing performance of the German K40. The tank used a gasoline engine, dangerous, inefficient, outdated. Worst of all, it was designed to be easy to build. German engineers believed ease of construction was a flaw. In their view, a weapon should be refined, not simplified. Each improvement justified complexity. Each added capability warranted a longer production time. This philosophy gave birth to machines like the Tiger, thickly armored, heavily armed, mechanically intricate, a masterpiece of engineering, a nightmare of logistics. By contrast, the Sherman looked like something designed by factory managers instead of engineers. Standardized parts, wide tolerances, components that could be swapped in the field. It was not elegant. It was not intimidating. It was not impressive. On paper. That paper mattered deeply in Germany. Combat reports that filtered back from North Africa were often filtered again by pride. Losses were attributed to tactical errors, insufficient support, poor positioning. When Shermans appeared in large numbers, the explanation was simple. America, German planners believed, relied on brute force because it lacked finesse. What they did not see, what they could not see from Berlin, was the ecosystem surrounding the Sherman. In Detroit, Lima, and Chicago, assembly lines ran in shifts that never truly stopped. Tanks were not handcrafted. They were flowing. Hulls moved forward whether or not an individual station paused. If a design change slowed production, it was rejected. If a component failed too often, it was redesigned for speed, not perfection. The Sherman was designed to be repaired by men with limited training, using tools that could be carried in a truck. Engines could be replaced in hours, not days. Tracks could be swapped without specialized equipment. When something broke, crews did not wait for factory experts. They fixed it themselves or replaced the tank entirely. Germany's engineers knew none of this in detail. They saw specifications. They saw thickness charts. They saw photographs. And they laughed. At Kummersdorf Proving Ground, German technicians fired captured Allied shells at test armor plates and shook their heads. Inferior, they concluded. Adequate at best. The Sherman, they agreed, would never survive a prolonged fight against German heavy armor. But the men in the field were beginning to notice something else. Panzer crews returning from Tunisia spoke of engagements that did not end when the enemy took losses. They spoke of American tanks reappearing after being written off, of columns that stretched beyond the horizon, of knocked-out Shermans replaced overnight. One Oberleutnant remarked bitterly that fighting American armor felt like fighting the factory itself. These reports unsettled frontline officers, but they failed to move the design bureaus. German engineering culture was rigid, hierarchical, and slow to accept criticism from below. If the tank was superior, then defeat must lie elsewhere. More armor, bigger guns, better optics, the solution was always more tank. And so resources were poured into increasingly complex designs. Thicker armor, stressed engines, heavier turrets, strained suspensions, spare parts multiplied. Training time increased. Each tank became a precious asset, too valuable to lose, too rare to risk. Meanwhile, the Sherman multiplied. By the time German engineers seriously considered modifying their production philosophy, the strategic situation had already shifted. The Americans were no longer learning how to fight. They were learning how to fight with abundance. And abundance, as the men in Tunisia were discovering, obeyed different rules. Back at Kasserine Pass, as darkness settles and recovery crews move among the wrecks, German officers count losses carefully. American wrecks are more numerous, but American engines are already rumbling in the distance, fresh tanks moving up. For the first time, German engineering certainty begins to erode, not because the Sherman is better, but because it refuses to disappear. January 1942, Detroit, Michigan. Snow clings to the edges of the River Rouge complex as whistles mark the changing of shifts. Inside, the noise is constant. Steel presses slamming, welders flaring, rivet guns rattling in rapid disciplined rhythm. This is not a factory building tanks. It is a factory flowing tanks. An M4 Sherman hull slides forward on rollers. Men do not admire it. They do not stop to perfect it. They do their task and step aside. Another hull follows immediately behind. Here, speed is doctrine. The United States does not design the Sherman to be the best tank on the battlefield. It designs it to be the most present. Engineers accept compromises deliberately. Armor thickness is good enough. The gun is versatile rather than specialized. The engine is chosen because it can be produced in enormous numbers and serviced by mechanics who learn their trade fixing trucks and farm equipment. Every decision answers the same question: how many can we build, ship, maintain, and replace? By mid-1942, American planners understand something Germany does not yet fully grasp. This war will be decided by systems, not single weapons. A tank that cannot be transported, fueled, repaired, and crewed in volume is not a battlefield solution. It is a liability. The Sherman reflects this philosophy in every bolt. Its transmission can be removed from the front without dismantling the hull. Its suspension is forgiving of poor terrain and hurried maintenance. Its parts are standardized across variants. A tank knocked out by mechanical failure is not mourned. It is cannibalized, stripped, and returned to service in pieces. When a Sherman breaks down, it is an inconvenience. When a Tiger breaks down, it is a crisis. This difference becomes brutally clear once American forces move beyond North Africa. July 10, 1943. Sicily. Shermans roll off landing craft, directly onto beaches still under sporadic fire. Salt water sloshes around their tracks. Crews wipe condensation from periscopes and move inland within minutes. Some tanks stall, others throw tracks. Recovery vehicles follow immediately behind, already trained for this exact scenario. German defenders note the same thing again. The tanks keep coming. In Sicily, and later in Italy, American armored units rarely fight alone. Shermans are nodes in a larger network. Infantry riding on engine decks, artillery on call by radio, fighter bombers circling overhead. When a German anti-tank gun knocks out a Sherman, the gun position is smothered with H rounds, mortars, or air attack within minutes. The Sherman's job is not to be invincible. Its job is to be replaceable. This truth is felt most sharply by German tank crews as the war moves closer to Europe's industrial heartland. They notice that American units accept losses in a way German doctrine never allowed. A destroyed Sherman does not halt an advance. It barely slows it. Commanders press forward, confident that tomorrow will bring more tanks, more fuel, more ammunition. German crews, by contrast, are ordered to preserve their machines. Withdrawal is preferable to risk. A damaged tank must be saved at all costs, sometimes even at the cost of ground. The psychological burden grows heavier with each engagement. American crews climb into new tanks with minimal ceremony. German crews climb into theirs, knowing they may never see another. By late 1943, the arithmetic becomes impossible to ignore. American factories are producing Shermans faster than German industry can produce anything comparable. Bombing raids disrupt rail lines, skilled labor disappears into the army or the rubble of cities. Components arrive late or not at all. A single missing bearing can sideline an entire tank. Meanwhile, American tanks cross the Atlantic in convoys protected by overwhelming naval power. Losses at sea barely dent the flow. When Shermans reach Europe, they arrive in numbers that defy German assumptions about sustainability. A German engineer might still scoff at the Sherman's armor profile or gun performance. A German tanker at the front is no longer laughing, because he has learned the Sherman's real strength. It does not need to win today. It only needs to be there tomorrow, and the next day, and the day after that. June 6, 1944. Normandy, France. Dawn breaks through low clouds as landing craft buck and grind toward the beaches. The sea is gray, choppy, unforgiving. Ramps drop, water floods in, and Shermans, some swimming, some already half submerged, begin their crawl toward France. German observers watching from bluffs above the coast report tanks immediately. Many are destroyed before reaching dry land. Mines erupt beneath tracks. Anti-tank guns punch clean holes through frontal armor. Flames rise, thick and black, marking the shoreline. To German officers, it looks familiar. This is what happens when inferior tanks meet prepared defenses. But by mid-morning, the beaches are no longer the killing grounds they were at first light. Smoke screens roll inland. Naval gunfire hammers known gun positions. Infantry pours off the sand and into the hedgerows. And behind them, more Shermans arrive. By noon, German units are reporting a problem they had not anticipated. Not that Shermans are hard to kill, but that killing them is no longer decisive. In the bocage country beyond the beaches, German tankers wait with confidence. The terrain favors defense. Narrow lanes, thick hedgerows, sunken roads, perfect ambush ground. Panthers and Panzer IVs sit hull down, engines idling, gunners pre-sighted on choke points. The first Sherman appears, then another. A quick exchange of fire. One American tank burns. Another reverses out of sight. German crews exchange glances. Just as planned. Then artillery crashes down, hedgerows erupt. Leaves and earth rain onto turrets. Radio traffic spikes. American forward observers are calling fire with practiced efficiency. Smoke rounds blind German optics. High explosive stun crews. Shermans reappear. Not one or two, but entire platoons, moving cautiously, covering each other, probing for flanks. A Panther fires, destroying a Sherman at close range. Its commander orders a reposition to avoid counterfire. The tank lurches backward, and its engine sputters, a mechanical fault. Minor, normally fixable, but under fire, with artillery falling and infantry advancing, the crew has seconds to decide. They abandon the tank. The Panther, the pride of German engineering, is left intact but useless. Later, American crews will inspect it with curiosity, photograph it, and move on. By contrast, Shermans damaged in the same fight are often recovered the same day, tracks repaired, turrets swapped, engines replaced. A tank destroyed in the morning may be back in service by nightfall, or replaced by another rolling off a transport truck. German infantry begin to notice something unsettling. Even when they stop an American attack, it feels temporary. The next push comes sooner than expected, with more tanks than before. Positions captured at great cost are lost again within days. German engineers had mocked the Sherman's tall silhouette. In Normandy, that silhouette becomes familiar, so familiar that soldiers begin to expect it, the way one expects bad weather. Reports sent up the chain of command grow more urgent. Requests for more heavy tanks, for more anti-tank guns, for more ammunition. But the answers come back thin and late. Production numbers cannot match losses. Fuel shortages ground vehicles before they reach the front. In contrast, American armored divisions seem inexhaustible. Fresh units rotate in. Crews gain experience without running out of equipment. Tactics evolve rapidly. Hedgerow cutters welded onto Sherman hulls. New communication procedures. Tighter coordination with infantry. German tankers face not just more Shermans but better used Shermans. The psychological balance shifts. German crews no longer wait confidently in ambush, they wait anxiously, aware that every shot reveals their position. Every kill invites retaliation from artillery, air power, and more armor. What was once mockery becomes frustration. Then respect, then something closer to dread. Not because the Sherman is superior in a duel, but because the battlefield is no longer a duel at all. It is a grind, and Germany is running out of steel, fuel, and time. August 1944, near Falaise, France. The air is thick with dust and smoke. Burned-out vehicles litter the roads. German trucks, horse carts, artillery pieces, and tanks abandoned for lack of fuel. In the distance, engines rumble steadily, unbroken by pauses or uncertainty. They are American engines. Sherman columns move forward with methodical patience. Vehicles halt, refuel, advance again. Damaged tanks are pushed aside, marked, and bypassed. The road belongs to momentum now. German armored units fighting their way out of the Falaise pocket do so under constant pressure. Panthers and Tigers that once dominated open terrain now struggle to even reach the front. Fuel convoys are destroyed by fighter bombers before they arrive. Spare parts never make it through shattered rail networks. Crews are ordered to destroy their own tanks when they can no longer move them. A Tiger sits intact at the roadside, its armor unscarred. The crew has blown it up with demolition charges, not because it was defeated, but because it could not be saved. Across the fields, Shermans advance without ceremony. They are not hunting Tigers. They are sealing roads, cutting escape routes, pressing the enemy into collapse. A Sherman platoon may lose 2 tanks in a day and replace them by morning. This is attrition in its purest form. German officers begin to speak openly about it. They note that every engagement costs them something irreplaceable. A trained crew, a specialized engine, a transmission that cannot be rebuilt in the field. American losses, by contrast, seem to vanish into an accounting system that always resets. One German report describes the situation bluntly. Enemy tank losses do not appear to affect their operational capability. That sentence, more than any penetration chart, captures the truth. In battles across France, Belgium, and into Germany itself, the pattern repeats. Shermans do not seek out superior German tanks head-on unless necessary. They fix the enemy in place while artillery and air power do the killing. They exploit breakthroughs rather than force them. And when they are destroyed, they are replaced without drama. German engineers had once assumed that heavier armor would naturally dominate lighter vehicles, but they had not accounted for operational reality. A tank that requires perfect conditions is fragile. The tank that tolerates imperfection thrives. By late 1944, German crews are exhausted. Veterans are gone, killed, or captured. New crews receive minimal training before being sent into battle. They face American units that have been fighting continuously since Normandy, supported by a logistical system that functions even under fire. The Sherman becomes a symbol, not of invincibility, but of inevitability. When German infantry hear its engine, they do not ask what model it is or what gun it carries. They ask how many are coming. And the answer is rarely comforting. In the Ardennes, German planners gamble everything on one last offensive, hoping weather and surprise will negate American advantages. For a moment, it works. Shermans burn in forested roads. Units are cut off. Confusion reigns. Then the weather clears. Fuel runs out, and the Shermans return, first in ones and twos, then in companies, then in entire armored divisions rolling forward with renewed confidence. The offensive collapses not because German tanks are inferior, but because there are not enough of them and they cannot be sustained. By early 1945, the equation is undeniable. German engineers may still argue technical merits, but the battlefield has rendered its verdict, where the Sherman has won not by being better, but by being enough, everywhere, all the time. March 7, 1945. Near the Rhine. American Shermans idle along muddy roads as engineers rush to secure an intact bridge. Tracks clatter across planks not meant for such weight. The crossing is risky, but hesitation is more dangerous than collapse. German resistance here is thin, not absent, but brittle. In factories that still stand, German engineers finally confront the reality they had long dismissed. Production numbers are reviewed again and again. Losses outpace output by margins that no redesign can close. Even if a perfect tank could be built tomorrow, there would be no fuel to run it, no trained crews to man it, no time to deploy it. Some engineers admit, quietly, what frontline commanders have known for months. The Sherman was never a joke. It was a different answer to the same question. Germany asked, how do we build the best tank? America asked, how do we keep tanks fighting no matter what? The contrast is visible everywhere. Abandoned German vehicles line roads, mechanically sound, tactically impressive, strategically useless. Nearby, Shermans with patched armor, mismatched road wheels, and welded repairs rumble onward, scarred, but functional. American crews have nicknames for their tanks. They personalize them. They expect them to survive, but they are not surprised when they don't. Replacement tanks arrive with the same serial efficiency as ammunition and rations. German crews, by contrast, have learned to mourn their machines before they are lost. Late-war German design proposals still chase technical excellence. New guns, sloped armor, innovative suspensions, none of it matters now. The war has moved beyond blueprints. As American forces push deeper into Germany, Shermans are everywhere. In cities, in forests, on autobahns. They support infantry clearing buildings. They blast roadblocks. They escort supply columns. They do the unglamorous work of occupation and advance. German engineers, touring bombed factories after surrender, will later remark on the irony. Their tanks often outmatch the Sherman in isolation. Yet isolation never existed on the modern battlefield. The Sherman operated as part of a machine far larger than itself. Industry, logistics, training, doctrine. To face it was to face all of those at once. In the end, the laughter stops. Not with a single catastrophic defeat, not with one famous duel, but with a slow, grinding certainty. Every time a Sherman appears, it brings with it the knowledge that more are coming, and that stopping them today will change nothing tomorrow. That is the lesson written across Europe in burned steel and broken roads. The Sherman was not a masterpiece. It was a promise, kept again and again.